We're solving the past questions, right? Okay, so I'll just continue from where we stop. Okay, actually this. All right, so let's continue. So I think we've done question 7. We're moving on to question 8. The next question says that the line y equals to the line y is equals to 5x plus 6 meets the curve meets the curve x y is equals to 8 at the point A and B to stop. So find the coordinates. Find the coordinates. Find the coordinates of A and B. Of A. Alright. So this question is coming from an area of maths. I'm not called coordinate geometry. Which I think is one of those topics that we should be looking at probably next time. Because if you look at our maths textbook, there are so many topics that are included. So this one is one of those topics that we need to look at. Right. So there are many ways of solving this problem. You can use your GeoGebra, your graph, and try and plot the graph two lines, and then see where they meet. So we'll start with that step. Thereafter, we'll now use the other method whereby we use some of the what they call it, principles that we learn in coordinate geometry. So using the GeoGebra method, I would like you guys should come with your laptop so that we can have a practical session. So from tomorrow or from the next class we are going to have, please come with your laptop. So meanwhile, here is my GeoGebra here. So I'm just going to show you from this view. Closer. So you go to your graphic. You know how to use it, right? So I want to get rid of this. I'm getting rid of what we have here already. GeoGebra makes it easy for you to visualize any mathematics that you are working with. So, and I love to use it while teaching so that whatever you are teaching will be as concrete as possible. Because maths looks boring when you're only dealing with letters. You are not dealing with something that is tangible. All right. So now I'm first going to plot the graph of y using the software is equals to 5x plus 6. Okay, and you see the graph. The straight line that goes through on your y-axis, it passes through 6, and on your x-axis, it passes through. So I can put my pointer there to find out exactly where it passes to minus negative 1.2. So when you plot this graph, it should go this way. All right, so now let me get rid of this.
So now let's plot the other graph. XY, I'll just type it in. You can do this at home. Is equals to what? 8. Okay. So in order for you to see the graph, so you have to move it around to see where it's actually presented. So now this graph is not showing for whatever reason, but I think the reason is because the two variables we are using so we're supposed to have one variable on one side and the other way. So what do you think we are going to do so that we make it to become y equals to something? So we can divide function by x, isn't it? So when you do that, you have y equals to 8 over what x. It's still the same thing as xy over xy over xy equals to 8. Can you see this now? So that's the graph. So now the solution to this graph will be, I don't know why it's not showing. Let me get rid of this again. Just like this. Okay, let me use f of x. You know, I can still use y to f of x. I hope you know that. You are aware of that, right? Let me just write it again. F of x equals to 8 over x. Let's see what comes out. 8 over x. It's telling me warning. So what's the warning all about? Need to figure out what's the problem. Say x times. Let me see what happens with this. Okay. So let's just see how we can. Okay, I think probably because I use f of x here. Let me try and use f of x is equals to 5x plus 6. So that one. So let me use a different function. So I'm going to use g of x equals to 8 over x. Okay, I think we'll just leave it this way. So now if you inspect where the two lines meet, inspection means just move your cursor. It has gone off again. Why is it actually going off? That's what I don't understand. Okay, so if I move my cursor here, I'll see this is -2, right? Isn't it? Okay, so I'll need to drag this one a bit. And then just for you to see the other. There are actually two solutions, that's what it means. So let me drag it down a bit. The other solution is when x equals to, I think, not really close to 1, but a bit close to 1, isn't it? Somewhere here. So let me just click on this place. So I think I'll need to use intersect for that. So let me go to my tools, intersection. Okay, so I go back to the graph, intersection for that. Let's see that again. So that's the intersection there. So basically we have two solutions. So that's basically what I want to show you. Well, I can shrink this. Let me shrink this. No, let me shrink this to be more smaller. Check that again. Let me shrink it again. Okay. Okay, so it's basically telling us that there's going to be two solutions. So one of the solution is at this point, is very close to 1. The other one is at this other point, which is actually 2. So you can go and play on it at home to find out the exact one. So now if you want to look at the solution using coordinate geometry, when we talk about coordinate, coordinate is just talking about graph and how to identify points on graph. For instance, if I want to specify a coordinate, like this point here is at 5, what do you call it, at 5 units towards the right, okay, and 5 units above. So by coordinates, I would say that point is located at 5, 5. So the coordinate is just a reference which I use to locate the position of the points. So that basically is that negative 5, 5. What I'm simply saying is that from the origin of the graph, negative means the left hand side. So you count 5 units along your horizontal and then 5 units above. So where the intercept is the position of the piece. So that's just a general idea of coordinates. So now we have this line and this line. For these two lines to meet where the intercept means that the solution to this will also be equal to this. So we started with the fact that y is 5x plus 6. So let's call this equation 1. The second equation says xy is equal to it. Call this equation 2. So now we have to solve the two equations simultaneously. Solving them simultaneously simply means substitute. Like substitution method, right? Or if you want to use the elimination method, you multiply equation 1 by let's say x, then you make your substitution. So let me use that method. So if I multiply equation 1 by x, so multiply equation 1 by x, I'll have xy equals to 5x squared plus 6x. Am I correct? Because x times y is xy. 5 times x times 5x is 5x squared. 6 times x is 6x. Alright, so let's call this equation 3. But there is something I know from equation 2 that the product of x and y is 8. So I can actually replace this x with y. So which means that multiplies that this becomes 8 is equal to 5x squared plus 6x. Which is actually quadratic expression because if you rearrange it, you get quadratic equation, right? So let's rearrange it. Taking this to the other side. So you now have 5x squared plus 6x minus 8 is equal to 0. You can use any of those methods. So we'll try and use the factor method. If it doesn't work out, then we'll try to use the what do you call it, the formula method. So let's try and see if we can use factor method for this. So to use factor method, we multiply the quotient of the whole of this term like this. So 5x squared times negative this is going to be negative 40x squared. Am I correct? So now you can find two terms such that the product of those two terms is going to give you negative 40x squared. And the sum of those two terms is going to give you 6x. So usually those two terms have to come from a factor of 40. So factor of 40, of course, you know, you can get it from your, let's say, 2 divided by 4, that's 20. 2 into 20, that's 10. 2 into 10, that's 5. Am I correct? And 5 into 5 is 1. So you can get all your factors from here. 2 is a factor. 2 times 2, 4 is a factor. 2 times 2, that's 8. 8 is also a factor. 2 times 5, 10 is a factor. 4 times 5, 20 is a factor. And 40. 1, 2, 3, 4, 5, 6. I don't know if there are other factors. But this is how many factors we get 2 to the power of 3 4 times 2, 8. There are no factors there anymore. This one are just basic ones. So pick any two factors that you multiply them together, it will give you negative 40x squared. And if you add them together, it's going to give you plus 6x. So what are those two factors that you will take? 2 and 4. Of course, you can't pick 2 and 4 because 2 times 4 is going to give you 8, not 40x squared. You get it? I believe they are using this method of finding if some of the product of the two tens is going to give you 8. Is that what you're using? Is that what you're doing? Yeah, that method works. So why the method fails is that when the quotient of x squared is not 1, that method doesn't work. So usually when I'm teaching my students, I use the method that works for all kinds of situations. So this one works for all kinds of situations. So you can't use 2 and 4 because 2 times 4 will give you 8. Or you can say minus 2 times 4 will give you minus 8, which is not the same as what? Negative 40 because you have to account for the quotient of that. So pick any other 2 factors that you can use. So basically those factors are going to come. 1, 2, 3, 4, 5, 6. There are 2 more of them. One is also a factor. And finally we have, I think, let me see, 1, 2, 3, 4, 5, 6, 7. 5 times 2, 10. 5 times 4, 20. 8 times 4 times 5, 20. 2, 4, 8. 2 to the power of 3 times 5 to the power of 3. 2 to the power of 3. 2 to the power of 3. That's 4. So pick those 2 powers. 200. Alright. So if you use 2 and 20, 2 times 20, or you can put a negative sign there. So negative 2 times 20, that's negative 40. But if you add it together, it will give you 6x. So this doesn't work. It doesn't work. So what about in the okay, I didn't pick 5. I think 5 is what is left. Alright. So I've completed the factors. So you have to pick those factors from here. 5 and 8. Okay. Or 5 plus 8 is 13. So if after trying any of those numbers and you couldn't get any, then it means the factor method cannot work with this kind of question. So you now have to use what we call the formula method. So looking at it, what of it we pick? Okay, so I think basically we pick most of what we need to pick. What is left is 1 and 40. You don't pick 1 and 40, then you're forced to pick 5 and 8. You don't pick 5 and 8, you're forced to pick 2 and 20. There's nothing else you can pick. Or 10 and 4. What of 10 and 4? Let me check 10 and 4. 10 and 4. 10 times 4, that's 40, right? And 10 minus 4 is 40. So let's try 10 and 4. Definitely should work out. So what are we going to do? So which one is going to be minus? Is it this or this? The 10, if the 10 is minus, then it's going to be minus 10 plus 4. That will be the negative, so it's going to be the 4. Not the 10. Alright, so now you have 10x and what? Minus 4x. So 10x times minus 4x will give you minus 40x squared. And 10x plus minus 4x will give you what? 6x. So that's the factor that works. So the lesson by learning is that you don't give up when you try maybe few of those numbers. You have to try it for as many times as possible before you can conclude that it is actually not what you cannot use the factor method to solve this problem. Okay. All right. So let's move on. So now the factor. So this now becomes 5x squared. So instead of writing plus 6x, so we write it in terms of those two factors that we have. So which is going to be what? Plus 10x.
minus 4x minus 8 is equals to what? 0. Do you understand? So we can now factor out the common, what is common between these two? 5 is common, or 5 and the highest common factor is 1. So factorize it completely. So 5 is common between these two, right? X is also common. So factor out 5x, what will be left with? So you'll be left with, so this is going to be x, right? Plus what is going to be here? 2. Are you following this? Then what's common between these two? Negative 4. Negative 4 into x plus 2 is equals to 0. Do you see that? So what is common again? X plus 2 is common. So x plus 2 multiplied by 5x minus 4 is equals to 0. So the product, if the product of two numbers is equals to 0, so it means either x plus 2 is equals to 0 or 5x minus 4 is equals to 0. You agree? So if x plus 2 is equals to 0, it means that x has to be what? Minus 2. So minus 2 plus 2 equals to 0. And if 5x minus 4 equals to 0, then 5x is equals to, taking 4 to the other side, that will be 5x equals to 4, which further implies that x equals to 4 over 5. So these are the two solutions to this equation. X equals to minus 2 and x equals to 4 over 5. We actually got one of them, the negative 2 from our graph. Then we got this one, which is very close to 1, because we got something close to 1, very round. So it's actually 0.8. Okay? So take down this before we move to the next. Is there no Yeah.
Right. So let's move. So the coordinates in question, so if you want to write your answer, the coordinate of A is, so we've not answered, we've not done with answering the question. So for the coordinate, you can say for A, the coordinate is at -2. You get it? That is the x coordinate. How do you get the y coordinate? You simply substitute the value of a -2 into any of the two equations. So I would like to go with this. So to get the corresponding value of y, that will be 5 into -2 plus 6. You get it? So it will be -10 plus 6, which is what? That's -4, right? -10 plus 6 is -4. So A is -2, -4. For B, we have 4/5, which is also the same thing as 0.8, comma. So what is the y coordinate? The y coordinate will be 5 into 4/5 plus 6. So 5 comes to 5. 4 plus 6 will give you 10. So that's the actual answer to the question. Right. Still on coordinates. So leaving this part of the book. Okay, so the next question says the points A and B are, so question 9, A is on the coordinate 4, 3, and B is on the coordinate 12, -7. All right, respectively. So the equation of the line L, the perpendicular bisector of the line AB is, so first of all, when you say perpendicular bisector, so if you draw the graph, of course I will illustrate it using GeoGebra, so let me just demonstrate it here first. So here is your graph, 4, 3 means 4 units to the right, 3 units above. So let's say it is somewhere here, just illustration. Of course, this is not exactly to scale, but it just is a way of describing how to solve the problem. Now B is at 12, -7. So 12 units away to the right. So let's say somewhere here. Please know that this is not to scale, so we're just going to use an estimate. And -7, which is going to be below. So let's say somewhere here. Then you get your coordinates for the B. So this is where B is located, and this is where A is located. So when you see the perpendicular bisector of the line, of course the line means you join the 2 points to the straight line. So this is the straight line. So the perpendicular bisector is a line that cuts this line into 2 equal parts. So let's draw the perpendicular bisector. And this line has to be at 90 degrees. So this is the line they are referring to. So the line passes through a point. Let's call this point M. For now, let's assume we don't know the point. Of course, we don't know it actually. So here is A and here is B. So that point where it passes through the midpoint, can we find it? There is a special formula used to find the midpoint of 2 line segments. So, and what do you need to do? So, all you need to do, if you want to find the midpoint of this equal 8, let's get the negative and do horizontal coordinate. For the horizontal coordinate, I'm going to look at for the vertical coordinate, sorry. So I'll look for the y coordinate, for the vertical coordinate. I'll look for the distance from this point above. So this point is 3 meters up, and how many meters down? -7 meters down. So the total distance is not going to be 3 minus 7, because the 2 points are on different opposite sides of the origin, the S axis. If they are on the same side of the S axis, let's say this -7 here, then the average is going to be 7 plus 3 divided by 2. Okay?
So if you go by the formula, the midpoint of the x coordinate is given by x1 plus x2 divided by 2. And the midpoint, y midpoint, mid, let's call this MID, is y1 plus y2. So the midpoint for, we've gotten the midpoint for the x coordinate, so for the y coordinate, just going to be 3 plus -7 divided by 2, which is going to be -4 divided by 2, which is going to be -2. So -2 is telling me that the point is actually below the x-axis. Alright, and 8 units away. Now, why is it important that we need to know? Because if a perpendicular line bisects a line, then by the word bisection, it means it has to divide it at the midpoint. So this information will be important for us in the future. Now, the line, perpendicular bisector of the line AB is given by, so we're giving the equation of that line to be y is equals to 4/5x plus, minus 42/5. Now, I actually want to take this in a very, very intuitive way. Intuitive way means that will make it more natural to your understanding. Because that's one of the challenges of students. Now, the equation of a line usually gives you information about two things. So the first thing it tells you about the slope. The slope is just telling you the way the line is being positioned. Okay? So 4/5 gives us the information of the slope of the line, while the remaining the constant 10 gives us the information about where it meets the y-axis. So in a nutshell, I say every straight line can be written as y equals to mx plus c, where m is what? The slope of the line, and c is the intercept of the y-axis. Intersect on the y-axis. Okay? And the slope by definition is just the rise or height over base. If you construct your triangle, the height of the triangle divided by the base gives you the slope. I think we discussed that in our class. So now, what are they asking you to do? So they are asking you to find the line parallel to AB, which passes through the point 5, 12. So let's find the point. So it's getting more complicated, right? Because there are so many points that are being used. But something that we need to take, there's something that we need to go home with. So those important things that we need to go home with is that, first of all, when we talk about a line is usually given by what? This equation. Okay? So the question of x represents the slope, and the slope is just telling you the height over the base or the rise over to the north. While the constant term is the intercept of the y-axis. So let's not worry about this. Okay? No matter how complicated it is. We'll take it little by little. So first thing, we know that there are 2 points. We first of all identify the position of those 2 points on our coordinate or graph. Then we are told that there is a perpendicular bisector that bisects this line, and it's given by this equation. So from this equation, what can we see? So we can say that the slope of that graph is 4/5, and the intercept on the y-axis is -42. So which means that if I'm going to, so let me clean all this, so we are no longer necessarily. So which means if I extend this graph, I'm going to cut this graph at 42/5, right? So the distance from here to here is going to be 42/5. Hope you get that. So let's not forget this information, very important. And since they are telling us that the slope is 4/5, so the slope being 4/5 means the rise is 4. For every 4 units you move up, then you move along the horizontal distance, how many units? 5 units. So if we want to use that idea, of course, we know this point is this, we've got the coordinate of the midpoint, right? And we know that the coordinate of the midpoint is 8 units to the left, right, and 2 units below. So let me just bring it here. So from here to this place is 8. Okay? From here to here is 8. And from here to this place is 2. So that's where the midpoint is located. So that is a line parallel to AB, which passes through the point 5, 12. So let's find where that point is going to be. So if from here to here is 8, and from here to here is 4, so the 5, 12, 5, let's start with 5. It's going to be between 4 and 8, right? So you can actually know where is going, that point is going to be. So let's say the point is somewhere here. So 5, 12. 12 means the height of the height. So let's check the height. So from the origin or the x-axis above, we have 12. So from here to here is 12. So I'm drawing the point in question. Okay, so this is the point. And we are told that a line parallel to AB. One thing about parallel lines, or if you draw lines that are parallel, so there is something that they always have the same slope. So permit me to clean this part of the board, because this is no longer useful for us. So lines that are parallel have the same slope. So for instance, if I draw my graph and I have a line and I draw another line, if these two lines are parallel, then their slope has to be the same. I think it makes sense intuitively, because slope is just telling us the extent to which the line is actually the way it is being positioned. So two lines that are parallel, the ratio of their rise to run is always going to be the same, irrespective of wherever place they are crossing the y-axis. So it also tells us that that line that is telling us that passes through these points must have the same gradient as what the line AB. But we don't actually know the gradient of line AB. We only know the gradient of this line that is bisecting this line. But there is a condition about two lines that are perpendicular to each other. So the condition says that when you have two lines that are perpendicular, their product of their gradient is always -1. So let's try and find the gradient of this other line. So the gradient of line AB, or the slope of line AB, is given by, so to get the slope, what you need to do is, you now say that it's the same thing as -1 over the slope of this line that is perpendicular to it. Okay, so why is that so? It is so because if I multiply the slope of this line by the slope of this line, the result is going to be -1. So let's say the slope of this line is m1, for example, and the slope of the other line that is perpendicular to it is m2. So m1 times m2 has to be what? -1. Okay, so since I don't know m1, so let m1 be m1 times what is m2? I know what m2 is. M2 is 4 over 5 is equals to what? -1. So if I make m1 subject to the formula, this will now become -1 divided by 4 over 5. And when you have the reciprocal of the fraction, means the fraction will be what? Be flipped about. So this is going to be -5 over 4. So therefore, the gradient of our line is -5 over 4. And of course, we know what the gradient means, the rise to the run. So what is the gradient of this line? So it means that that line that they are telling us that is passing through these points. Okay? There are so many information, it's looking kind of complicated, but if you get the basic idea, 1, equation of the straight line. 2, condition for two lines to be parallel. So for two lines to be parallel, two parallel lines have this equal slope. Do you get it? So the condition for two lines to be parallel means that their slope has to be equal. Then for two perpendicular lines, the product of their slope has to be -1. So for two perpendicular lines have the product of their slope. the minus 1. Do you get it now? So that's the difference. So key things you need to know: equation of the straight line, condition for two lines in parallel, and condition for two lines in parallel. So since the line is parallel to this line AB, so which means it's going to have the same gradient as this. So the gradient of that line is what? -4/5. So what did they actually ask us to do? They said we should find the line parallel to AB, which passes through the point 5, 12, intersects L. L is this perpendicular line. So you just have to take it a little by little because it's really, really complicated. But trust me, if we can take it one by one, it's going to be more clearer to us. So intersect L at the point C. So this line that is parallel to this passes through this point. This advance, that's why advance is there's a lot of information that is different from ordinary mathematics. Okay, so it passes through this point and meets this perpendicular line. So they're asking us to find the coordinates of that point. So remember in our previous question we did, how do you find the coordinates, the solution to those two equations, x y equals to e and y equals to 5x plus 8? We simply intersect, we simply draw when they intersect. And when they intersect, this is where the two equations are. When their y value of their y are the same. So we are going to do something similar here. Why are we doing something similar? Because we already know the equation of this perpendicular line to be y equals to 4/5x minus 42/5x. Yeah. So we already know. So it's also reasonable for us to actually find the equation of this line that is parallel to this line passing through this point. So we are going to go back to this equation. So going back to this equation, remember I told you those things that you keep that are very important for you. This condition of parallel to this. The other things are just techniques. So now let's find the equation of this line. We know the equation for every straight line is y equals to mx plus c. So y equals to, already we know what n is because we've gotten it from the condition that this line and this line are what? Perpendicular to each other. So what can you remember the problem of the slope again for this line? Calculated it from good. So that would be -5/4x plus. So what is left is this constant, which we have not gotten. You get it now? Now to find the value of the constant, we simply use the fact that since this line, because the equation of a straight line is just telling us the locus of every point lying on that line. So and this point lies on the line. Am I correct? This point that is at 5 units to the left, to the right, and 12 units above, isn't it? Yes. So if this point lies on the line, that means it has to satisfy this equation. So if we want to say satisfy this equation, which means that on the y-axis, I can say when y is 12, what will be the value of x? Plus x has to be 5. Am I correct? For it to satisfy this equation. So times 5. Do you see the trick now? Plus c. So which now becomes what? 12 equals to -5 times 5. That will be -25/4 plus c. And since we are looking for c, we make c subject to the formula. So taking this to the other side, that becomes 12 plus 25/4 equals to c. So you can find the LCM. LCM is 4. 4 times 1 is 4. 4 times 12, 48 plus 4 divided by 4, 1. 1 times 25, 25. So 48 plus 25, that's I think 73, isn't it? So c is going to be 73/4. Any question? Is it clear to you? It looks complicated, but it's not really that difficult if you can just know those questions. So this line has its own equation to be y is equals to -5/4x plus 73/4. Okay, so we are almost done. So all we just need to do now is to find the limit. We just equate these two together and solve for x. That's all. So let's try and do that. So I'm just going this part to the top. So equating these two, so we have 4/5x. I think I can even write it this way: 4x minus 42/5. Since 5 is common, isn't it? Equals to negative 5x plus 73/4. I think I can do this right. Since 4 is common. So now I'll cross multiply. So if I cross multiply, so our 4 times 4, that's 16x. 4 times negative 42, that would be negative 168. Isn't it? Is equals to, so 5 times negative 5x, that's negative 25x, plus 5 times 73, that would be, let's start from first, 5 times 3, that's 15, 5 carry 1, 5 times 7, 35, 35 plus 1, that's 36. So now calculate your like terms. So bringing this to the right side, everyone is 16x plus 25x is equals to 365 plus 168. Can you see that? So adding this, doing the maths, 16 plus 25, that will give you 36, right? Am I correct? No, not 36. 6 plus 5, that's 11, right? That's 41, isn't it? 41x is equals to 365 plus 168. Please come with your calculator. 5 plus 3, that's 3. 6 plus 6, 12. 12 plus 1, 13. So that will be 533. So therefore, x is equal to 533 over 41. And let's try and use calculator and see if 41 and 50 that. So try and use the calculator. 533 divided by 41. Then you remember. So this is going to be exact. So x equals to 30. But since the same coordinates, so it's not just going to be x, you have to find the y. So how do you get the y? Because once you are putting the two equations together and substitute to any of the equation. So how we going to substitute to the first one. So this first one, use the whole of this one. So y equals to 4x minus 42 over 5. Okay? So what will be 4 times what's x? 13 minus 42 over 5, which is 52 minus 42 over 5. 52 minus 42 is 10, right? 10 over 5 is 2. So y equals to 2. So the coordinate of that point is 13. That is from here to this place is 13. So it's actually beyond where this b is by the value of what we have. So it's actually beyond where b is. So from here to this place is 13. And 2 means is somewhere below this point where it is. Alright. So it looks so complicated. I don't know if you have any question. Is it clear to you? So let's try and use GeoGebra to confirm what we have just done. So to use GeoGebra, I'm just going to go to my GeoGebra. It's always good to use GeoGebra so that you can have a visual understanding of what you're doing. So I'm going to delete this and delete this. Okay, so first of all, we have 2 points A and B, 4, 3. So I'll just go and select the coordinate. I think I should zoom this. Yeah, so this is better now. So the first point is as 4, 3. So I'll go and pick my tools. So I'll pick points. So 4, 3 means from here to here is 4, right? So this is where it's going to be. Do you see that? That's B. B is 12, what? -7.
12 is going to be, so I'll just shift it a bit. That's 12. -7, I'll go down. Sorry, I'll take it off. Negative. So I'll keep track of where that should be. So it should go down like this. -7. Right? That should be the point. So that's B. So I have to draw a line segment. So I think I should reduce this scale so that I can see things. So I'll pick a line segment. So I connect this to this. That's the line there. So I want to get a perpendicular bisector. So I don't need to get midpoint because I already have functions that can help me do that. So I just pick perpendicular line bisector, select perpendicular line, and then point. So you can actually pick any point you want. Okay. Perpendicular bisector, I will need the midpoint because I can actually put it at any place. So let me take that again. So first, let's get the midpoint. There's a function for midpoint there. This is midpoint. So once you click on it, you see select the 2 points. So I'm select here and select here. So that's the midpoint C. So I can now use my perpendicular bisector. Select this and then, sorry, I'm not doing the right thing. Select the line, not point. So I'm selecting the line and then that's the point. Do you see it now? Graph makes it so easy for you. So we've gotten that line. So the next thing they said that 5, 12, there's another line parallel to it. So let's get the 5, 12. So I have to zoom this thing out a bit. Zoom 5. Okay, that's actually 5. Let me zoom this. So 5, 12. I think we'll go up. 5, 12. So I'll go up. That's fine. So this 5, 12. So I have to go and pick my points. Okay. So this is 5. So this is the position here. That's it there. So what they say? So there's a line passing through that point parallel to. So let me reduce this a bit. And go down and go up. So the line is parallel to this line, right? AB. So I'll go and use parallel lines. There's a function for parallel lines. So this is it. Select parallel line and one point. So this is the line parallel to this. This is now passes through that point. So I've gotten that. So what they actually asked me to find is the intersection of this line and this line. So I'll go and pick my intersection. I think this is our last topic because my place is very far, so I have to leave before. So this is where they meet, isn't it? So can we inspect the points? You have to use this one to inspect. So let's inspect. Okay, so let me, I think, zoom it out so that everything can. This zoom it out or zoom it in? No, it should be zoom out. So let's zoom out so that those coordinates that are not showing will show. Okay, so do you see that? 13 and what? 2, which is what we also got while using our, what do you call it? The principles that we learned. So these things are not as difficult as you see them. Take time to practice. Especially when you have GeoGebra now, when you try and do your calculation, try and do the experiment and see if it's agree. If it doesn't agree, then watch some videos. So you need to know, to enjoy math, to like math, you have to make it like an activity, like chemistry, physics, and all those, whereby you have to actually do an experiment. So you use these tools so that your knowledge of maths can increase and it's going to show in your performance. Any question? All right, so there's no question. I think we'll wrap it up here.